Guys, welcome back. Welcome back to Manchester. If you were aware, there was a guy who sent me an email this morning from an airport. He still hasn't got back to Manchester. Anyway, so nice to see you again, guys. So today I'm going to do this. There are only 2 questions for you to do. Sheet 8. Both questions are on the Neyman-Pearson lemma. Remember, the last thing we did before the Easter break was the Neyman-Pearson lemma, right? And I managed to do just one example. I just did one example on the use of NP lemma, right? And so, can you take a few minutes and see if you can do question 1? Can you take a few minutes and see if you can do question 1 by yourself, guys, using the NP lemma, right? Let's do question 1, please. Try and see if you can do question 1, guys.
Oh yeah,
Are you sure I'm just the X of X?
Guys, can you do question 1, please? I know, just before the Easter, we talked about the Neyman-Pearson lemma. I only did one question. So maybe I will show you.
Question 1, yeah.
Guys, shh. Can you listen to me, please? I know, before the Easter break, I did only one question on the Neiman Pearson lemma. So let me do just question 1 for you, just to help you to do that question 2. Okay? So can you please listen to me? So here, you have three IID observations from a Poisson distribution with parameter lambda. Okay, and we want to test the hypothesis that lambda equal to 1 versus the alternative that lambda equal to 2. Now, if you look at the NP lemma or the Neiman-Pearson lemma in the lecture notes, it says we reject the null hypothesis if we reject the null hypothesis if the ratio of the likelihood at 1 divided by the likelihood at 2 is less than a constant c. This is what the NP lemma says. Yeah. Okay. Now I'm going to show you how to simplify this in a minute. Right. Now this is the same as, these pens never work really, guys. Come on, guys. Trying to find a pen that works. All right. The likelihood at 1 is this is the likelihood at 1, and the likelihood at 2 and this is the likelihood at 2 is less than a constant c. Right? Now, this is 1. Now 1, if you power 1 to anything, that is equal to 1, and this guy here will cancel out with this guy. So what you have guys, is this. Do you guys follow this or not? I just simplified this to this, right? Now, furthermore, you can simplify further. Now, guys, let me ask you something. What have I done from this step to this step? What have I done? I have taken the log both sides. So taking the log of the left and the log of the right, you get this on the left and this on the right. Okay? Now I'm going to divide the left and the right by minus of 2. So that will become this will become this. You see the sign the less than sign changes to greater than sign because I'm dividing by a negative number, right? When you divide by a negative number, you need to switch the signs, right? So this is the rule for rejecting the null hypothesis, right? Now, for the sake of notation, let me call this K. You can call it any other name, but let me call it K, right? All right, guys. Now the next thing I want to do is how to determine how do we determine the value for K in practice. To do that, I'm going to use the third part of the question, which says that alpha, the value for alpha is 0. Remember, you should remember from before the Easter, alpha represents the probability of type 1 error, right? You guys recall that or no? You don't? It's the probability that. Come on, guys. I thought you guys are revising, or no? You don't recall this? It's the probability of type 1 error is equal to 0.1, right? In other words, the probability that you reject H0, given that H0 is true, which is yes. Now the probability, according to the Neyman-Pearson lemma, this is x1 plus x2 plus x3 greater than k, given lambda equal to 1 equal to 0.1. Right? Now we know that each xi, that is x1, x2, and x3, are IID Poisson variables. There is a property of Poisson which says that you choose some independent Poisson variables, then the sum is also Poisson. Right? So in this case, the sum of x1 plus x2 plus x3 will be Poisson, with the parameter being 3 lambda, because the parameter will be the sum of the parameters for the 3 variables. So it is lambda plus lambda plus lambda, right? Okay. You guys following or lost? Okay, so since lambda is 1, this becomes the probability that a Poisson variable with parameter 3 is 0.1, right? And this equation can be solved numerically for k, right? So in other words, I mean, to solve this equation, you need to use a computer software or computer package, or there are certain books that contains tables for the Poisson distribution, not the table that you will get in the exam, but there are books I have seen in the past that contains tables for the Poisson distribution. You can use those tables to solve this kind of equations, right? So the answer to the question, to answer question 1, all right, this is, so the answer to the question 1, part 1, part 2, part 3 is that by the Neyman-Pearson lemma we reject the null hypothesis if the sum of three variables is greater than k, where k satisfies equation star. Is that clear or you lost? Because I did this because I had did only one question like this before the Easter break. So I wanted to give you some hope, some hint on how to do questions like this. All right? Is that, yeah? Yeah, I already done this in the past. I have already done it. Is that clear? It's clear to all of you guys. How is that? You alright? Alright. Can you now do question 2, guys? If that is okay with you guys, can you do question 2? Can you move to question 2, please now? Guys, can you do question 2 if this is clear to you? If this is not clear, please ask me or shout at me. How are you guys? You're right, sir. It's kind of look close. Are you right? You guys have a good break. Everybody sign this? What about you guys? Can you sign this? You guys okay? How are you guys doing? You guys okay? You guys okay? Good.
Can you take out the two and this? So you know down to the end. Because that's not you can just take it off.
It's on the explanation.
Yeah, it is. It is. Like that.
This is the whole of question 1. Normally you can only find this in the computer
You just get rid of the E, so it'll just be
Yeah, so I don't want to get the one oh yeah.
Alright guys, let's get started. Alright, it seems some of you are struggling. I don't know. Let's see.
That's right. Because like that and that is positive, so when you put it positive on that side, it'll still be nice.
yeah, got two things are positive. These are positive. Then if you take it away, it's definitely still going to be less. Take away something positive, it's still going to be less. Take away something positive, it's less. So this and less. it's definitely not going to be SL.
All right, guys, shh, could you listen, please? This is question 2. So the question is the same kind of question, is to find the most powerful test, which basically means apply the NP lemma, right? So by the Neyman-Pearson lemma, we reject the null hypothesis if the likelihood at sigma 0 is less than some constant, say c, right? This is the rule the NP lemma says, right? Now we know that we have a random sample from the normal distribution, so the likelihood, guys, is the product of right, is the product of the density of the normal distribution. So this is the density of the normal at sigma 0, mean 0, this is sigma 1, right? You see a few things will cancel. This guy and this guy will cancel. So what you get is yeah, this is what you, yes guys, right? Now you can simplify this further to this, and this put together will become sigma 1 and sigma 0, and this will give you yes. Are you guys with me? Right, now I'm gonna take this guy here. I'm gonna take this guy to the right hand side. So this will become okay. And the next step is I'm going to take the log of the left and the log of the right. So you should take the log both sides. This is what you will get. And finally, I'm gonna, well, before finally, all right, I'm gonna do the following trick, because in order to get the answer that we want, we need to divide this by sigma 0 squared. And since we have divided by sigma 0 squared, we need to multiply. We also need to multiply by sigma 0 squared, right, in order to cancel the effect. Right now, so this will become. Now you should divide the left and the right by this factor here, right? You will get the following. You get right. This is. Do you see why the less than has changed to greater than? Do you see why? Why have I changed the less to greater than? Because this guy here, this is a negative number, right? So when you divide by a negative number, you need to change the less to greater, right? The reason that this is a negative number is because, if you read the question, guys, it says sigma 0 is less than sigma 1, and therefore this one is a negative number, right? Okay. So now, for the sake of notation, let me call this K, right? So the rejection rule, the rule for rejecting the null hypothesis is that the sum of xi squared divided by sigma 0 squared is greater than K. Okay. That's the first part of the question. The second part is to find the value of K when alpha is 0.05. Right, so this is part 1. Part 2, this is part 1. So let me take, are you guys done with this or no? Yes? All right. So part 2 of the same question. Is to find K so that alpha is 0.05, which means that the probability of type 1 error is 0.05, which is the probability of rejecting the null hypothesis, that is when sigma is equal to sigma 0 is equal to 0.05. Now, I know you guys have been revising. Can you tell me what distribution will this have and why? Given that sigma is the population standard deviation is equal to sigma 0, what distribution will that have? Come on, guys, you should know on top of this, on top of your head. You should know what that is. You don't remember? Anybody? Let me show you what it is. If you look at page 17 on equation 75. If you look at equation if you look at equation 75 of the lecture notes, you will see that this must have the chi-square distribution with n degree of freedom. It's on page 17, 17. Right, therefore, K must be the percentile of the chi-square distribution with the probability exceeding equal to 5% or 0.05. So that completes part 2. Is that remember, the way I write percentiles is different from other courses. When I write suppose this is 5%. Suppose this is 5% of the total area. Then this point here, according to my notation, this point will be chi-squared n 0.05. All right. So it's the area to the right-hand side for me. Right-hand side for me here. Okay. Is that clear, guys, or no? Yeah. Yeah. Yes. All right. Now part 3 of question 2 is to find beta, which is the probability of type 2 error, when n equal to 10, sigma 0 is 2, and sigma 1 is 3. All right. Let me go to do part 3 of question 2 is we want to find beta, which is the probability of type 2 error, right, which is the probability that you remember guys, from before the break, you will know you accept the null hypothesis when H1 is true. So you can write this as the probability that you can write this as this is the probability that you would accept the null hypothesis, right? Remember, accept is the opposite of rejecting. So we reject, in part 2 we saw that we reject the null hypothesis if it's greater than k. So we will accept the null hypothesis if it's less than or equal to k, right? Now here you must realize that the true standard deviation is no longer sigma 0, it's equal to sigma 1. So the first thing you must do is to change sigma 0 to sigma 1. Sorry guys. The first thing you must do is this is P, guys, P. I'm replacing sigma 0 by sigma 1. So I need to multiply by the same and divide by the same. Now once again, by Now, before I go to that step, okay, let me rearrange this. Let me take this guy here to the right hand side, so this becomes yeah. Now once again, by equation 75, if you look at equation 75 in the notes, printed notes, you will see that this guy here, because we are conditioning on the fact that this true sigma is equal to sigma 1, this must have the chi-square distribution, right? So this is the probability that a chi-square variable with n degrees of freedom is less than or equal to right. All right, and this you can write as, if you like, you can write it as a CDF of a chi-squared n variable, yeah, at okay. All right. So this is the answer to part 3 of question 2. Now you can obviously sub in the values. I mean, the question 2, part 3 says it gives you specific values for sigma 0, n, and sigma 1. So you can sub them in and work this out, right? I'll see you guys in a few minutes. Now for the class from 4 to 5, bring all the questions you have for the test tomorrow. Don't panic for the test. It will be really easy, guys. I'll be disappointed if you don't do well. Yeah. Equation 75. Equation 75 is n. The one before that is n. I'll show you. If you have the notes, I'll show you that. I'll have it here on the board. It's equation 72, madam. So this equation is n minus 1. But I used equation 75. This is n. This is 75. This is n. Yeah.